We're looking at the different types of AIs and the characteristics of these different types of artificial intelligence systems. At the beginning, we have an AI agent. This is something that tries to perceive, understand its environment, taking different actions to achieve its objectives. Basically, it's something that will react to its environment. So let's think about those different environments, okay? So we get something like an AI system that tries to understand the inputs of us humans. We give an input, such as ChatGPT, can you tell me about the weather today? And it is then going to understand the words that we have given to it. Its environment is basically an input of text in this case. It understands certain things, such as, okay, there's the word weather. What do I associate with weather? How can I come up with an information which I could provide to this human on weather? It's going to look up on its maybe latest weather forecast and other things like that. In other words, it is a way of trying to understand the inputs that it got, react in the environment that it has. This is a text-based environment to finally give an output that will be acceptable to its user. Symbolic AI tries to look through the different structures that it has been given rules and will try to give an output according to those rules. You have a system that's been told that it should, say, show the different ethnicities of the world. And I'll tell you where this fails. And so at the early days of Gemini, people asked, please show me an image of the founding fathers of the United States. And of course, it tried to follow its rules. Its rules was you should have a certain number of ethnicities represented. Okay, let's say the Indians of North America were shown there. We had a certain number of Black Americans that were represented on the image that it wanted to show, and a few Asians. And as much as I would have loved that the founding fathers of the United States might have been a diverse cast of people from around the world and genders and different creeds and beliefs, that actually was not the case. But you can see from that it had been trained on certain rules to give an output. And a symbolic AI is going to manipulate these kind of bodies and structures to behave in a way to give an output that supposedly would be the best one. A sub-symbolic AI here is where you have a system that has an implicit encoding of information. In other words, it's getting things directly from experience or raw data, whereas the symbolic AI was really getting things that were more structured. On sub-symbolic AI, we have things, an AI system is going to give things from the environment itself. It's going to try to understand things with fewer human inputs. It's been getting less teaching from human. It's going to try to derive from experience or the raw data itself, being given fewer of the rules. So here, to give our example of the founding fathers being a diverse cast which didn't represent the historic record, it might look at thousands and thousands of pictures of the founding fathers and come to the conclusion that sadly the races of the world were not represented amongst the founding fathers, and maybe give you something that was a little bit more historically accurate. Let's say it as it is: white men in their 60s who were writing the Constitution and doing the different historical acts that we know of. Approaches to machine learning. We start at the lowest level with supervised learning. This is machine learning that uses only labeled data during training. In other words, when you're feeding the system different images of animals, we're telling the AI system, this is a dog, this is a cat, this is a dolphin. And it's then going to be able to look at new images, infer from that the ones that are closest to the images that it knows to be dolphins. They live in the water. That might be a good hint. In semi-supervised learning, the machine learning that uses both labeled and unlabeled data. We've, say, split the pictures in two. We're going to label half of them, we say it's a dog, a dolphin, a cat, and the other, we're just going to leave it open and maybe see how well the system is labeling the other half of the data that was unlabeled. Here it's semi-supervised learning. In unsupervised learning, we are just throwing the AI into the deep end of the pool and has to understand what the data is. It's going to get an understanding from the data sources that we have. These are the kind of models that are trained on a very large variety of things. So maybe it cannot directly say what a cat is if it were only given images, but if it's given access to training data that includes texts, say 100,000 Reddit posts, a lot of which say that this little fuzzy creature is a cat, then it's going to be able to by itself understand that this thing is a cat according to the 10,000 Reddit posts that tell me that this is a cat or that associate the word cat with the image of a cat. Now, if there had been a practical prank and everyone started calling bottlenose dolphins cats, maybe the AI system could get tricked into thinking that a dolphin were a cat. But if it's given proper data, good data in, then it should be able to identify in an unsupervised way. And finally, reinforcement learning is where you've had these previous steps of learning, but that you are giving it reward through different interaction with its environment. So the idea here is that this works really well on, for instance, AI systems trying to work on computer games. Okay, let's go back to the basics. Okay, Super Mario has just a few buttons, up, down, left, I think jump, and maybe throw a fireball. In any case, it has those little actions, inputs, and it has an output, which is going to be reaching the end of the level with the most coins in the least amount of time and having lost the fewest number of lives. It understands that those are targets that it should achieve by modifying the inputs, move right in the right direction rather than left. Left doesn't seem to be an action bringing it closer to the end of the level, and so it is not going to be able to understand that as a proper action. And so if we give it these targets, go as far as you can through the level, then it is slowly going to be able to understand how to get better at doing those things. We can guide it in certain ways. We can reinforce the learning by giving it targets to better achieve an action. Let's look at the types of AI based on capabilities. At a lower level, but I'm not going to say that this is like an evolution, okay? Let me just say that this is not an evolution because I think that the best system, AI system or other system, is the one that can best achieve the task without potentially being distracted by other things that could create problems for the system itself. And so you want your system to be as smart as it needs to be for the uses that it's going to have without it necessarily being able to do everything. Do you need your AI chatbot from the Chevrolet Tahoe dealer to actually be able to compute advanced mathematics and maybe tell you about quantum physics? No, you probably don't. It needs to be dumb enough where it could not give bad answers in a more likely way. It needs to be focused enough in a narrow AI context. Then you have general AI, an AI capable of performing a variety of tasks similar to human intelligence. This is where basically it would be just like a human in many or most fields, where it would be able to have a general outreach. And I'm going to say that some of these systems that we have nowadays can do a lot of things, but they're still limited in their environment. ChatGPT can basically talk about anything for which it hasn't been restricted. Let's avoid certain adult-related topics, for instance. But it can talk about things in many different fields without necessarily any big restrictions, except the ones that are from its structure itself. But it gives output in text or image or video, or it gives output in quite a few forms, but it's still limited in what it can do. And finally, strong AI. This is where we'd have cognitive capabilities similar or even superior to those of humans. As I said, the day that AI is as good as humans, the next day it is far more capable of humans. And I'm not going to say this is a progression, but I'm just saying that when you're actually thinking for a management system how intelligent you want your AI system to be, I would say restrict it to the absolute minimum that you want, and you set a maximum that it should not go beyond. Your AI system does not need to understand quantum physics to grant a loan application. Let's look at types of AI systems based on cognitive capabilities. We had at the beginning reactive machines. These are AI systems that react only to current stimuli. Stimuli is basically different things that we are feeding as input to the system. And it is only going to be able to react to the things that we give it. It is not going to be able to do something that is different from that system. This is good in an extremely large number of cases where we do not want a system to be doing more than it should, where we have something with limited memory, an AI that uses past experience to make short-term decisions. Now, think about your loan granting AI. Okay, this is a highly sensitive system, but you'd want an AI that can maybe understand the past interactions with the client, but maybe it shouldn't understand or at least remember the confidential data that was given to it from past clients. Maybe it shouldn't. You do not want a system that could be queried for what the previous client actually gave as inputs. So limited memory is good, but you have to make sure what you're actually giving as limited memory. We have the theory of mind, where you have an AI capable of understanding even through emotions and the thoughts of others. And I'm just going to say here we're talking about philosophy. We're not necessarily talking about something that an AI data engineer is really going to be working on a daily basis. We're really talking about things that are nearly philosophical context, philosophical debates about when has a thinking machine reached our level of human emotions and understanding. Will AI ever be able to do that? That is, quite frankly, not for me to discuss that. I'm going to leave that for the philosophers. And finally, we have self-aware artificial intelligence, as you've seen in the movies, which is AI with self-awareness and the ability to reflect on itself.